Let's look at the solutions of number system bytes. Find the remainder when 7777 up to 37 digits is divided by 19. So a variation of Euler is n repeated p minus 1 times upon division by p, where p is prime. This leads to a remainder of 0. So given that we are dividing it by 19, 18 repeated sevens is divisible by 19 because it is up to 37 digits. So I can get rid of 36 digits straight away. And I'm left with 7 divided by 19. Answer to the question is 7. Next, what is the remainder when 13 raised power 2013 is divided by 100? If I'm looking for remainder with 100, I'm looking for remainder with 4 and 25. Remainder with 4 is straightforward. 13 leaves a remainder of 1. 1 raised to any power would be 1 only. So 4n plus 1. Now when I'm seeking remainder with 25, the repetition would happen after every 20. So effectively, what I'm seeking is 13 raised to the power 13 upon division by 25. What remainder does it leave? So this is as good as 169 raised to the power 6 into 13, whole thing divided by 25. Now 169 upon division by 25 leaves a remainder of minus 6. Because it is raised to an even power, doesn't really matter. It is as good as 6 raised to the power 6 into 13 divided by 25. Again, now 6 cube leaves a remainder of minus 9. 6 cube is 216. So this is 6 cube raised to the power 2 into 13 divided by 25. 6 cube leaves a remainder of minus 9. Minus 9 upon division by, or even if you want to go down the path of 6 cube leaves a remainder of 16. 16 square is 256, or minus 9 raised to the power 2 is 81 into 13 by 25. 81 leaves a remainder of 6, so I'm left with 6 into 13 by 25. 78 leaves a remainder of 3. So remainder with 25 is 25k plus 3. So I'm now seeking a number which is 4n plus 1 and 25k plus 3. The smallest such number is 53. Upon combining, we get that. So 100n plus 53. 13 raised by 2013 is 100n plus 53. Remainder upon division by 100 is 53. Next, the first 131 natural numbers are written side by side to form the number n, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. If n is divided by 5625 and the remainder so obtained is r, then find the value of r. Okay, 5625 is 9 into 625. If I want remainder with 9, I need sum of the digits. The best way to get that would be 131 into 132, sum of first and natural numbers, divided by 2. This is sum of the digits. Cancel, cancel, I get 66. Given that we finally only need remainder by 9, I can simply add up the digits also. This will turn to 5, this will turn to 12, this will turn to 3. So 5 into 3, I've got 15 by 9, or remainder with 9 is 6. So the number that I'm dealing with is 9n plus 6. This gives me remainder with 9. Now I need remainder with 625. For remainder with 625, I need remainder with last 4 digits. Last 4 digits are 0131. So not a problem at all. Directly I can get to 625k plus 131. I have to combine these two now, which is not a straightforward task. Okay, so we'll go down the path of 9n is equal to 625k plus 125. Okay, so now 9n is equal to 621k plus 4k plus 117 plus 8. So 4k plus 8 has to be a multiple of 9. The best value of k that we can see is 7 because 4 into 7 plus 8 is 36, which is a multiple of 9. So k has to be 7. So the smallest such number or the number that we are seeking is, see, k is coming out of this. So the number has to be 625 into 7. 7 into 5, 5, 3 carried over. So 7 and 1 carried over. So 4375 plus 131. So I get 6 from here, I get 0 from here, I get 5 from here, I get 4 from here. So the remainder that we get for this setup is 4506. Okay. Next question. What is the remainder when 10 raised per 43 plus 12 raised per 43 is divided by 121? Okay. Hopefully we can see that we can write this number as 11 minus 1 raised to the power 43 plus 12 minus 1 raised to the power 43. If I open it up using binomial expressions, first I will work with this. I will get 43C0 into 11 raised to the power 43 into minus 1 raised to the power 0 plus 43C1 into 11 raised to the power 42 into minus 1 raised to the power 1. Can you see 121 is nothing but 11 square? So all these terms that have 11 raised per 43, 11 raised per 42, 11 raised per 40, 11 raised per 32, so on and so forth, all of them are divisible by 121. The only terms that will not be divisible by 121 are the last ones, which would be 43C42, 11 raised to the power 1 into minus 1 raised to the power 42 plus 43C43 11 raised to the power 0 into minus 1 raised to the power 43. These are the only two terms that are not divisible by 121. Everything prior to this is divisible by 11. Okay. So from here we get 43 into 11 and from here we get minus 1. We have done this work for 11 minus 1 raised to the power 43. Let us do same work for 11 plus 1 raised to the power 43. Hopefully you can see the writing process is going to be pretty much the same. So on and so forth. All the terms would be multiple of 121 except the last two, which would be 43C42 11 raised to the power 1 into 1 raised to the power 42 plus 43C43 11 raised to the power 0 into 1 raised to the power 43. So just for the last two terms, what I would get is 43 into 11 plus 1. I need summation of these expressions. What remainder do they leave upon division by 121? So 43 into 11 and 43 into 11. I would get 86 into 11. I'm not caring about this minus 1 and plus 1 because they would cancel each other out. So 86 into 11 is as good as 946. So I have to divide 946 by 121 and see what the remainder is. So 946 by 121, 7 times. I would get 847. So the remainder that is left is 99. Answer to the question would be 99. Last question. Y is equal to 1 factorial whole square plus 2 factorial whole square plus so on and so forth up until 100 factorial whole square. What is the remainder when y is divided by 1152? Now 1152 is, let's see how much. This is 128 into 9 or 2 raised to the power 7 into 3 square. Can you see for 3 square, remainder with 9, 3 factorial onwards, 3 factorial onwards, every 3 factorial square onwards, everything would be divisible by 9. So if I only want remainder with 9, I need 1 factorial square plus 2 factorial square whole thing divided by 9, which gives me 5 by 9. Remainder with 9 is identified. It is 5. Now when I need remainder with 128, see 6 factorial square would be equal to 2 raised to the power 1, 2, 3, 4, 4 into 3 square into 5 whole square. 6 factorial I've written within the brackets and square outside. Can you see this leads to 2 raised to the power 8 into 3 raised to the power 4 into 5 square. This number is definitely divisible by 128. So if I want remainder with 128, everything 6 factorial onward square is useless for me. The only portions I need is 1 factorial square plus 2 factorial square plus 3 factorial square plus 4 factorial square plus how much? 4 factorial square plus 5 factorial square. So I have 1 plus 4 plus 6 square is 36. 4 factorial is 24. 24 square is 576. 5 factorial is 120. 120 square is 144. 0, 0. Whole thing divided by 128 I have to see. Now I know under this there is 512. 512 to 576. So this will leave a remainder of 64. Okay. Under 14400, I can get 12800 cancelled out straight away. I'm left with 1600. Under 1600, I can get 1280 cancelled out. I'll be left with 320. Under 320, I can get 256 cancelled out. I'll be left with 64. Okay. Now 64 plus 64 is divisible by 128. I can get that out. So I'm left with 128k plus 41. So these are the two numbers. I have to combine them. 9n plus 5 is equal to 126k plus 36 plus 5 here plus 2k here plus 2k here. Okay, let me get rid of 5s. This 5 and this 5 will go away. Effectively, this portion is a multiple of 9. If 2k has to be a multiple of 9, k has to be 9 itself. K has to be 9 itself. So 128 into 9, or 128 has to be 0 itself. Oh, it has to be 0 itself. It has to be 0 itself. So the smallest such number would be 41 itself. If k is put in as 0, I get a number which is 9n plus 5 and also 128k plus 41 sort of number. So the answer to the question has to be 41 itself. That will be all for this episode. I'm pretty certain not everybody would have understood all the questions, because in remainders, especially, there is a problem that different people have different nomenclature. The way I do remainders, I have a universal way. I always look for remainders and combine them. So whatever way you have done it, great. If you understood what I did, also great. If you did not, I would recommend you go back to your teachers and ask them how remainders are coming out. This entire sheet is dedicated to finding out remainders, different setups, different remainders, how to work with them, what is combining and everything. Hope you learned something. Okay, people, bye.